So today we will see about acid properties in DBMS. So I hope you are aware with the term DBMS. DBMS stand for Database Management System. For example, Oracle, SQL Server, MySQL, PostgreSQL, etc. and so on. Alright, so this is DBMS, Database Management System. Now we have to see about acid properties, what these are. This is a very important topic in DBMS, Database Management System. But before proceeding towards acid properties, you should be clear with the term transaction. So let's see what is a transaction. What is a transaction? Everyone should be clear with this term transaction. What is a transaction? Any unit of work which we do either to access the database or to modify the database is a transaction. Okay, let me write. What is transaction? It is a single logical unit of work that access the database, access or modifies the database. Alright, so transaction is a single logical unit of work that access or modifies the database. For example, if I'm writing a query, I'm writing a SQL query, let's say select star from employees. So this is a transaction and it is a single logical unit of work. And what this transaction is doing, this is accessing the database, because I'm saying to select all the data from the employees. So this transaction is accessing the database. So this is transaction. I hope you are clear with the term transaction. So let's get back to our topic, acid properties. But always there is a one question: before understanding the acid properties, we should know why we follow acid properties, why there is a need to follow acid properties. What will be the question? Why we follow acid properties? What is the need of acid property and why is it so important? So what will be the answer? Answer is the very basic, and that is we follow acid properties to maintain consistency of the database after and before the transaction. Why we follow acid properties? We follow it to maintain consistency of the database before and after the transaction. So we follow ACID properties to maintain consistency of the database before and after the transaction. Now you should be clear with the term consistency. So what is consistency? Sometimes we say that data is consistent, right? So data is consistent means if for example let's say there is a table. In that table there is a single column, and in that column if we are storing numeric value in that column, then only numeric values should be allowed in that columns. What I am saying, if there is a column in which we store numeric value, then only numeric values should be allowed, right? I mean to say, if there is a column ID and we are storing numeric values in this 1 2 3, then only numerical values should be stored in that column. Like we cannot store character values in that columns. So this is about consistency. So now what we are saying here is ACID properties are used to maintain the consistency of the database before and after the transaction. Consistency and integrity of the database have to be maintained. That's why we use ACID properties. So I think when I explain you the things more about atomic properties, ACID properties, then you will be get more familiar with the term consistency and integrity. So let's start our ACID properties. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. First one is atomicity. What this property says? This property says that the entire transaction takes place at once or doesn't happen at all. Let me write this. The entire transaction takes place at once or doesn't happen at all, right? the entire transaction take place at once or doesn't happen at all. It means like if we are performing some operation, then that operation should not be executed partially. Operations should not be executed partially. Either operation should be completed at all or it will not be completed at all. Alright, for example, let's take this query as an example. Where is that? Yeah, this one. So again I'm writing query select star from employees, and suppose employees is a table in which there are two columns. First one is the ID, let's say three columns. First one is ID, second one is name, and the third one is salary. Alright, and this is our transaction. Alright, so either we get the three columns of the table when we are writing star, either we won't get any of the column from the table and we get any error. There will be two possibility. First one is we get all tables, all columns. Get all columns from the table. Second one is second possibility will be no columns at all. We get error. What I mean here is, if we are writing select star from employees, then either we get ID, name, salary, either we will get any error, right? It will not be like we get ID column, we get name column, but we are not getting salary column if we write star. So this is about atomicity. Either we will get all columns from the table or we will don't get any column from the table. So operation should not be executed partially. This was our atomicity property. Let's see our second property, which is consistency. Now what this property says, that this property says database must be consistent before the transaction and after the transaction. Database must be consistent before and after the transaction. Let's see an example for this. For example, we have a user A and a user B. Alright, in user A account we have $100 and in user account there is $20. And what will be the total amount in both the accounts before the transaction is? It will be 300, because 100 plus 200 is 300. This is before transaction. Alright, Now what is the transaction? In the transaction we are saying A, please transfer $50 to B. This is our transaction. Now we know that transaction should be atomic. We should follow atomicity. Either complete transfer is to B or there will be no transfer of $50 to B. So after the transaction, what amount will be left for A is $50 and B is with $250. And what will be the total amount of both the account? It will be 300. So this is consistency property. Database must be consistent before the transaction and after the transaction. So this was our second property, consistency. It says that database must be consistent before and after the transaction. Let's see our third ACID property, which is isolation. So as isolation means remain far away from other, remain in your isolation, stay single is isolation, no interference from outside, that is isolation. Same is in the case of DBMS. Isolation says that no interference if multiple transactions are occurring. No interference if multiple transactions are occurring or running. For example, let's say some transaction is between A and B. A is sending 50 rupees to B, and some transaction like another transaction in between B and C. B is sending 50 rupees to C. Alright, so now there will be no interference in this transaction T1 and no interference in this transaction T2. T1 will not interfere within T2 transaction, T2 will not interfere within T1 transaction. If A is sending 50 to B, then it will send A 50 to B, it will not send 50 to C directly. Alright, if B is sending $50 to C, it will send $50 to C. T1 will have no interference in the transaction T2. So this is about isolation, no interference in between T1 and T2. T1 transaction will not affect T2 transaction, T2 transaction will not affect T1 transaction. So this was our property isolation, which says that no interference if multiple transactions are occurring. I hope this is clear. Now let's see our last property, which is durability. Now, as I already told you, ACID properties are to maintain the consistency and integrity of the database. Sometimes it happens that like your transaction is successful, it is completed successfully, there is no issue in between, your transaction is now completed and it is a successful transaction. So what happens when your transaction is completed, and suppose you have done your transaction is successfully completed, there was no any error, it is completed, but a power failure occur or a system failure occur, then you lost your data, you lost your data after you were getting the transaction. You lost that data which you was getting after the transaction. So now what will happen? It will harm our database. For this there is a property which is called as durability, and what this property says, that it says that after the completion of the transaction, the updates you have made to your database, the modifications you have made to your database are stored permanently. They are not stored temporarily, they are stored permanently, so that any system failure doesn't harm the database changes. So what does durability says, that changes made in the database after the transaction are stored permanently. Alright, changes are stored permanently, so that any kind of system failure does not harm the database change. Let me write this one also, so that any kind of failure, system failure, does not harm the database change. So this was our last property, durability. I hope you are clear with this. Now what we will say about these properties is, all in all, ACID properties is to ensure that the database is consistent and correct. What we will say, ACID properties is to ensure that database is correct and consistent. So ACID properties stand for atomicity, which says that either the transaction is completed successfully or it is not completed at all. No partial execution. And what is consistency? Changes before and after the transaction should be consistent, right? We already discussed database must be consistent before and after the transaction. And what is isolation? Isolation property says that no interference between multiple occurring transactions. And what durability says, that durability says that if transaction is made, completed successfully, then those changes should be stored permanently, so that any kind of system failure or power failure does not harm the database change. So this was our ACID properties. I hope you are clear with this ACID properties. Thanks and goodbye.